Hello friends, this video on coordinate geometry part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. Let me introduce you to a new section called sectional form. The first question that should come to our mind is, why do we need sectional form? I'll give one real life scenario. So let's suppose this is a road. This is a road which the government has constructed. This is a road, right? This is a road actually. This is my road. In this road, the government is planning to put some street lights in such way that in this 4 street lights can fit in this distance. So we know the starting point of this distance, xy coordinates, and we know the starting point of this point, that is xy. Here the government wants to create 4 poles, equidistant. So one pole it can create here, electric pole, electric light. One electric light it can create here. Now for the next 2, what it will do? If you see this, if you divide into 4 equal half, 1, 2, 3 equal half, you get 4 points here. So if this is x, this is x, this is x, all x. This points divide this line into x by 2x. You see this point. If we're talking about this point will divide the line in the form of 2x by x. Correct? Now using sectional formula, we can find the x and y coordinates for these points. If we have the line segment, if we have the endpoint, and if we have the ratio in which the line segment is dividing, for example, in this case we have x by 2x, it's 1 by 2 in first case, and 2 by 1 in the second case, we'll get the xy coordinates, and once we get the xy coordinate, we can install the street lights. This is one real life example why we need sectional form. Any place when you have a line segment or when you have a distance, you have the endpoints, you have the coordinates, and you want to find a coordinate at different points where you know the ratio with which the line is divided, you can find the coordinates using sectional formula. So that is brief introduction. Why do we need sectional formula? So let's derive sectional formula. So first, if you have this point A and B with coordinates x1, y1, x2, y2. So let's suppose this is my point A and this is my point B. This is x1, y1 and this is x2, y2. So we have 2 points. Now, if there is a point which divides this line into ratio, let's suppose m1 is to m2. In our case, m1 by m2 was 1 is to 2 in case 1 and 2 is to 1 in case 2. So let's take the general ratio m1 and m2. Then this point will be denoted by this value. X coordinate will be mx2 plus m1x2 plus m2x1 by m1 plus m2, and the y coordinates will be m1y2 plus m2y1 by m1 plus m2. Please remember this formula, it's a very crucial formula. How it is, I'll tell you. m1 x2, if you take this m1, you multiply x2, m1 x2 you get. Then you get m2, you multiply x1, you get m1 x1 and divide by m1 plus m2. Similarly, same thing with y1 y2. You take m1, you multiply with y2, m1 y2. You take m2, you multiply with y1, you get m2 y1. m1 y2 plus m2 y1 divided by m1 plus. To prove this, we'll have to draw a graph like this. This is the point AB actually, if you see. This is point A and this is point B. And this is the point B which divides this AB in ratio m1 is to m2. So let's draw this triangle. This triangle is drawn. And we'll try, how to do this? We'll try to prove that they are similar. The triangles are similar. If the triangles are similar, we can compare the sides ratio. And then we can find the value of x and y. How? If you see this is x2, y2. So that means this point is x2. Correct? And this point is somewhere y2. This point is x1, y1, so this point is x1, and this point is somewhere y1. This is xy, so this point is x, and this point is somewhere y. Correct? You know how we have done? This is x1, y1, so this point is y1. If you take this point to the y-axis, this is y1. If you take this point to the x-axis, this is x1. This is xy, so if you take this point to the x-axis, this is x. If you take this point to the y-axis, this is y. Similarly, this is x2, y2, so if you take this point to the x-axis, this is x2. And if you take this point to the y-axis, this is y2. We have all the points. Now, AQ will be x minus x1. Correct? Distance of AQ will be equal to RS. See, let's first find the values of all these things. I'm telling the approach first. We'll try to prove they are similar, and then since we'll have this AQ, PQ, everything in the form of x, x1, x, m1, m2, we can solve this equation to get the value of x and y. That's the approach we'll follow. So let's try this. We'll try to prove that these two triangles are similar. So if you see, these lines are all parallel, because they are all parallel to x-axis or perpendicular to y-axis. So angle P will be equal to angle A, and this angle Q is equal to angle C, 90 degree. So we can say that in triangle BPC and triangle PAQ. I am taking BPC and PQ because angle B is equal to angle P, right? Angle P. This angle P is equal to angle A, and angle C is equal to A. You can say that angle BPC is equal to angle PAQ. Why? Because PC is parallel to AQ, they are corresponding angle. PC is parallel to AQ. It's parallel in the right. Also, angle Q is equal to angle C. Why? 90 degree. Therefore, triangle BPC is similar to triangle PAQ. Now, since they are similar, the sides will also be similar. So, sides, if you see, is nothing but BP. If you take BP, you take PA here. BP by PA is equal to, if you take PC, you take AQ. PC by AQ, and if you take BC, you take PQ, equal to BC by PQ. So BP by PA is M1 by M2. You know this. This is M1 by M2. PC by AQ. Next is PC by AQ. So what is PC? PC is x2 minus x. If you see, PC is equal to ST, and that is x2 minus x. So PC is x2 minus x. Sorry, this is m2 by m1. BP by P is equal to m2 by m1. m2 by m1. PC is equal to x2 minus x, and AQ. AQ is equal to x minus x1. Why? Because AQ is equal to RS, and RS is equal to x minus x1. This is x minus x1 is equal to BC. Similar to BC is equal to this value, that is y2 minus y is equal to y2 minus y by PQ. PQ is equal to this one, y minus y1, y minus. Now we'll solve this equation. So we'll take these two things first, this two. So if you take these two, what we'll get? M2 into x minus x1 is equal to m1 into x2 minus x. Take x common, m2x plus m1x, this value and this value taken, is equal to m1x2, this value taken, plus m2x1. This will take this side, this becomes m2x1, or you get x is equal to m1x2 plus m2, this is x1, sorry, m2 x1 by m1 plus m2. Why? Because if you take x common in this, you get m1 plus m2. So this is the value of x. Similarly, we'll take the value of y. We'll take in this area, we solve in this area. So we'll take this equation in this one. So what we get? m2 by m1 is equal to y2 minus y by y minus y1, or we get m2y minus m2y1 is equal to m1y2 minus m1y. Correct? If you take this y, this here, you get m1 plus m2 into y. This is equal to, this is nothing but m1 by 2 plus, this is m2 y1, or we get y is equal to m1 by 2 plus m2 y1 divided by m1 plus m2, and that is the value of y, and this is the value of x. So if you see, this is what I was talking about, m1 x2 plus m2 x1 by m1 plus m2, and y is m1 y2 plus m2 y1 by m1 plus m2. Very simple. If you see, m1, you take this m1, you multiply with this factor m1 x2, you take this m2, multiply with this plus m1 x1, m1 x2 plus m2 x1, divide by m1 plus m2 is common in both. For y also same thing, you take m1, multiply with y2, m1 by 2, and you take m2, you multiply with y1. So m1 y2 plus m2 y1 divided by m1 plus, try to remember this formula. This formula is very, very crucial. We'll have to solve a lot of questions based on this formula. There are some special case of sectional formula. So if we are talking about the midpoint of 2 points, then m1 by m2 is equal to m1 by m2 is equal to 1:1. Why? Because if you have 2 points A and B, then we are talking about midpoint C, and it is the midpoint. So if this is x, this is also x. So m1 by m2 will be equal to x by x. That's 1 by 1. So in that case, if you use the formula, x came out to be m1 x2 plus m2 x1 by m1 plus m2. So put both m and m2 is equal to 1 and 1. So it becomes 1 into x2 plus 1 into x1 by 1 plus 1. That is x1 plus x2 by 2. Similarly, y is equal to nothing but m1 by 2 plus m2 y1 by m1 plus m2 is equal to 1 into y2 plus 1 into y1 by 1 plus 1. That is nothing but y1 plus y2 by 2, and that is my answer. So if you see, in special case, if we are talking about the midpoints for 2 points x1, if this is x1 y1 and this is x2 y2, then the midpoint is x1 plus x2 by 2, and this is y1 plus y2 by 2. This is a special case of sectional formula. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.